Hi, this is Dr. Shubhangi Vaikore, working as an associate professor in computer department at Dattamegi College of Engineering, Airoli. Now, in this video, we'll see the first chapter of Artificial Intelligence and Soft Computing subject, that is Introduction to Artificial Intelligence and Soft Computing. In the previous video, we have seen the first topic, that is Introduction and Definition of Artificial Intelligence. In that video, we have seen what is the definition of artificial intelligence, then how the AI is categorized into 4 dimensions, such as the system that think like humans, the system that act like humans, the system that think rationally, the system that act rationally. Then we have seen the foundation of artificial intelligence. Then we have also seen the history of artificial intelligence, that is how the artificial intelligence has evolved from start to till date. Then we have seen the various applications of artificial intelligence. Now in this video we'll see the second topic, that is intelligent agents. In this, we will see the agents and environments, rationality, nature of environment, structure of agent, and types of agent. So now, first we'll start with intelligent agents. So what do you mean by an intelligent agent? An agent is anything that perceiving its environment through sensors and acting upon that environment through actuators. We can give the example as the human is an agent. Yes, human is an agent. The human perceives the knowledge from the environment and the human acts on the environment through the various actuators. Robot is also an example of an agent where the cameras are used to perceive and the motors are used as the actuators. Then thermostat, detecting the room temperature, is also an agent. There are various characteristics of the intelligent agent that are divided into the internal characteristics and the external characteristic. The internal characteristics are, first one is learning or reasoning. An agent has the ability to learn from previous experience and to successively adapt its own behavior to the environment. Second one is reactivity. An agent must be capable of reacting appropriately to information from its environment. Then next one is autonomy. An agent must have both control over its action and internal states. The next one is goal oriented. An agent has well-defined goals and gradually influence its environments. So this learning, reasoning, reactivity, autonomy, goal-oriented, these are the internal characteristics of the internal agent. Now we'll see the external characteristics. The external characteristics are communication. An agent often requires an interaction with its environment to fulfill its task, such as human, other agents, and arbitrary information sources. Next one is cooperation. Cooperation of several agents permits faster and better solutions for complex tasks that exceed the capabilities of a single agent. Then mobility. An agent may navigate within electronic communication networks. Then character, like human, an agent may demonstrate an external behavior with many human character as possible. So these are, that is communication, cooperation, mobility and character. These are the external characteristics of intelligent agent. Now we'll see the diagram of the intelligent agent. In this diagram, you can see the environment is perceived through the sensors by the agent. Then the agent reacts or the acts on the environment through the actuators. Now, this is also one of the representation of intelligent agent. In this diagram, it is represented that the environment is perceived through sensors. then actuators are used to perform the actions on the environment. Now if you see in this diagram, there is one box that contains the question mark and which is labeled as what AI should fill. So in this we'll see, depending on the percept, how the agent reacts or how it is decided that which action an agent should take on the environment. So now first we'll see the simple terms as percept and percept sequence. What is the basic difference between a percept and a percept sequence? So percept is nothing but a agent's perceptual input at any given instant. And percept sequence is what? It is a complete history of everything that the agent has perceived. So the agent has perceived at suppose t is equal to 0 time 1 percept, then t is equal to 1 second percept, then t is equal to third percept. So the sequence of this percept is called as the percept sequence. In general, an agent's choice of action at any given instant can depend on the entire percept sequence observed to date. Now here, I would like to give the example of the agent, sensors and actuators. Just we revise this. So for the human agent, sensors are eyes, ears and other organs, and the actuators are hands, legs, mouth and other body parts. For the robot agent, the sensors are cameras, infrared rangefinders, and the actuators are various motors. For the software agent, yes, the software is again a type of agent. So for the software agent, the sensors can be keystrokes, file contents, network packets, whereas the actuators are display on screen, writing files, sending network packets. So these are the various agents, sensors, actuators and their percept and percept sequence. Now we'll see the next term as agent function and program. So the agent's behavior is mathematically described by the agent function, a function mapping of any given percept sequence to an action. So there is a mapping between a percept sequence and a action, and this mapping is called as the agent function. So you can also say that the abstract mathematical description is called as the agent function. Now what is agent program? Practically, the agent function is described by the agent program. The real implementation is called as the agent program, or you can say the concrete implementation. So the agent function is implemented by an agent program. So hope it is clear what is agent function and what is agent program. Agent function is just abstract mathematical description, whereas the concrete implementation of that description is called as the agent program. Now here I would like to give the example of vacuum cleaner world agent. Now here the agent knows that there are two squares, A square and B square. So there are two locations. Then the vacuum agent perceives which square it is in and whether there is dirt in the square or not. It can choose to move left or right. For the vacuum cleaner world agent, the perception is clean or dirty, whether that square is clean or dirty, and the location of that agent, whether the agent is in square A or it is in square B. And depending on the percept sequence, the different actions taken by the vacuum cleaner world agents are: the agent can be able to move to the left, move to right, he is able to suck the dirt or do nothing. Now in this table, the agent function is represented, that is vacuum cleaner world. In this, the percept sequence, suppose the agent is present in the A square and the square is clean. Then the action taken is, then the agent will move from A square to B square. So the action is move to the right. If the agent is present in the A square and the square is dirty, then the action taken by the agent is suck the dirt. If the agent is present in the B square and the B square is clean, then the action is move to the left, that is go to the A square. If the agent is present in the B square and the square is dirty, then the agent will suck the dirt. Now these are the percepts. So percept sequence can be is present in A and that particular part of square A is clean. Then he will move from one part of A square to the second part of A square. So again A clean, and the action is right. If he is present in a particular part of A square and that particular part is clean, when he move from that part to the next part, and if the next part is dirty, then the action taken is suck. So in this way, the abstract mathematical description is represented in this particular table, and that is nothing but the agent function or the simple agent function for the vacuum cleaner world. Now we'll see how that agent function is implemented. So in this we'll see the function, that is program that implements the agent functions. So the function is the reflex vacuum agent, location and status, return and action. So based on his location and based on the status, he will return an action. And depending on the situations like this, if status is dirty, then action is suck. Else if location is A, then he will move to the right. Else if location is B, then he will move to the left. So this is the agent program. Now hope it will clear the difference between the agent function. So the previous slide represents the agent function and this slide represents the agent program. Now we'll see the performance measure. The performance measure means what? It is an objective function that determines how the agent does successfully, whether the 90% of dirt is cleared or the 30% of dirt is cleared. It is described with the help of performance measure. An agent based on its percept, that is action sequence, if desirable, it is said to be performing well. No universal performance measure for all agents. Depending on the situation, depending on the type of application, the performance measure will differ. Now, we'll see the general rule for the performance measure. Design performance measures according to what one actually wants in the environment, rather than how one thinks the agent should behave. So whenever we want to design the performance measure for any application or any task or any agent, we should keep in mind these 2 points. What we want in the environment rather than how one thinks the agent should behave. So in example, in vacuum cleaner world, we want the floor clean no matter how the agent behave. Means whether the agent clears first A square or B square, this is not important. We want both the squares clean. We don't restrict how the agent behaves. Again, we cannot tell the agent that first clear the A square, then B square. This sequence also doesn't matter. We just want the square to be clean. Now, next topic is the rationality, the concept of rationality. Now, a rational agent is an agent which has clear preferences. It models uncertainty via expected values. Anything that makes decision. So one that does the right thing is called as a rational agent. Every entry in the table for the agent function is correct, or it is said to be rational. Then what do you mean by correct? What is correct? The actions that cause the agent to most successful. So we need ways to measure success. So if my action leads to a success, then I can say that my action is correct. Otherwise it is wrong. So rationality is what? It is a status of being reasonable, sensible, and having good sense of judgment. The rationality implies the conformity of one's belief with one's reason to believe. It is also one's actions with one's reasons for actions. Then what is rational at any given time depends on 4 things. The performance measure defining the criteria of success, the agent's prior knowledge of the environment, the action that the agent can perform, the agent's percept sequence up to now. So this four things affects on the rationality. Then for each possible percept sequence, a rational agent should select an action expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. So always our aim is to maximize our performance. We can give the example of an exam. So suppose whenever we want to appear for the exam, always our aim is to maximize the marks based on the question on the paper and based on our knowledge. Then the next one is the example of a rational agent. So performance measure is awards 1 point for each clean square. So for the vacuum cleaner world agent, we can give the performance measure as for each clean square, we can give the award of 1 point. So at each time step, over 10,000 time steps, we can give the points. Then prior knowledge about the environment means whether the geography of the environment is known to the agent or not. So in the vacuum world, the agent knows that there are only two squares, A square and the B square. But the dirt distribution and the initial location of the agent is not known. The effect of the action. The clean squares, if we give the example of the vacuum world, then clean squares, then stay clean. And if there is a dirt, then suck the dirt. Then left and right actions, move the agent to left and right, except when this will take the agent outside the environment. Suppose the agent is present at the edge of the B square, then he should not move to the right. Otherwise, he will take out of the environment, in which case the agent remains where it is. Actions that can perform. He can move left, right, suck and no operation. The percept sequence, where is the agent, whether the location contains the dirt or not. So under this circumstance, the agent is said to be a rational. Its expected performance is at least as high as any other agent. Now, next is a concept called as omniscience. Now, what is the meaning of omniscient agent? An omniscient agent knows the actual outcome of its actions in advance. There is no other possible outcomes, however impossible in real world. So suppose if the agent knows that if I take action A, then what will be my outcome? Then the agent is called as the omniscient agent. But in the real world, it is not possible. Suppose we give the example of a crossing a street. Suppose my action is I am crossing the street. If there is no other factor affecting this, then if I cross the road, then I'll reach to the second part of the road. But what happens if when I'm crossing the road, certain thing happens, some emergency comes, then we can't possible outcome. So based on the circumstance, it is rational. As rationality maximizes the expected performance, perfection maximizes actual performance. Hence, the rational agents are not omniscient. Rationality is not the same as perfection. Now, the next one is learning. So, rational choice depends only on the percept sequence to date. We must also ensure that we haven't inadvertently allowed the agent to engage in decidedly under-intelligent activities. Now, what is the meaning of this? A rational agent should choose the looking action before stepping into the street. So we always say that when we cross the road, we should look in the left, we should look in the right, and everything is good, then cross the road like this. Because looking helps maximize the expected performance. Doing actions in order to modify the future percepts called information gathering. So learning is what? A rational agent is required not only to gather information but also to learn as much as possible from what it perceives. So, does a rational agent depends on only current percept? No. The past percept sequence should also be used. This is called learning. After experiencing an episode, the agent should adjust its behaviors to perform better for the same job next time. Next topic is autonomy. If an agent just relies on the prior knowledge of its designer rather than its own percepts, then the agent lacks autonomy. A rational agent should be autonomous. It should learn what it can to compensate for a partial or incorrect prior knowledge. We can give example here of a clock. There is no input, run only on its own algorithm, that is prior knowledge, no learning, no experience, etc. So we can say the clock is an example of a autonomy. Then next one is the software agents. Sometimes the environments may not be the real world. Example, flight simulator, video games, internet. They are all artificial but very complex environments. Those agents working in these environments are called software agents or the softbots because all parts of the agent are software. Now we'll see the nature of environments, that is the task environments. Task environments are the problems while the rational agents are the solutions. So whenever we want to solve any particular problem or any particular task, that is called as the task environment, and the agent which we are using to solve that particular task are the solutions. So how to specify the task environment? So basically the task environment is described with the help of PEAS descriptor. So here the P stands for performance, E stands for environment, A stands for actuator, and S stands for the sensors. Now what is performance measure? It specifies the performance expected by the agent. What we expect from the agent is performance measure. Then environment is what? It specifies the surrounding condition where the agent has to perform a task. So your around the condition represents the environment. Then what is the meaning of actuators? It specifies the tool available for the agent to complete the task. Then sensors, it specifies the tool required to sense the work environment. So with the help of PEAS descriptor, the task environments are specified. Now let's take an example of the automated taxi driver. So here the performance measure, first we'll see how the performance measure, environment, and this is described. So performance measure, how can we judge the automated driver? So for the automated taxi driver, how we can decide the performance measure, which factors are to be considered? So the factors can be getting to the correct destination. Yes, we want to reach our particular destination. Then minimizing the fuel consumption. Again, we are interested in minimizing the fuel consumption, minimizing the trip time and or cost, minimizing the violation of traffic laws or traffic laws. Always our aim is to avoid the violation or at least to minimize the violation of traffic laws. Then maximizing the safety and comfort. So these can be the performance measure. Then next one is the environment. What can be the environment for the taxi driver? A taxi must deal with a variety of routes, traffic lights, other vehicles, pedestrians, the stray animals, road works, police cars, etc. Interaction with customer. So all these things that is encountered by the taxi driver is the environment. Then next one is the actuators for outputs. The control over the accelerator, steering, gear shifting and braking, a display to communicate with the customer. So these are the actuators. Then what are the sensors? For inputs, detect other vehicles, road situations, global positioning system to know where the taxi is. Many more devices are necessary. So these are the PEAS descriptors for the automated taxi driver. Now here in this diagram, we can see the agent type as taxi driver. Here the performance measure describes what qualifies, then environment represent where it should act, actuators represent how will it perform action, and sensors represent how it will perceive the environment. Now we'll see the various examples of agent types and their PAS descriptors. So the agent is medical diagnosis system. So for the medical diagnosis system, the performance measure is we want the healthy patient. We have to minimize the cost and we have to follow the lawsuits. The environment is patient, hospital, staff. The actuators, the screen displays used to question, test, diagnosis, treatment and referrals. Then sensors, keyboard, it is used to entry the symptoms, then finding of patient answers. So these are the PS descriptors for the medical diagnosis system. The next one is the part picking robot. So here the agent has to pick the part and that pick part is to be placed in a correct bin. So here the performance measure is the percentage of parts in correct bins. What the percentage of the parts that are placed in the correct bins represent the performance measure. Then environment is conveyor belt with parts, bins, actuators, jointed arm and hand, sensors, the cameras and joint angle sensors. Then the next agent is interactive English tutor. So when we interact with the English tutor, my performance measure is the maximize the student score on test. Obviously we have to maximize the student score, therefore we are taking the help of the interactive English tutor. Then the environment is the set of students, the internet, and all this comes under the environment. Then actuators, the screen display, exercises, suggestions and corrections for this the screen displays use. Then the sensors are the keyboard. Then the next agent is the satellite image analysis system. Here the performance measure is correct image categorization, environment is downlink from orbit satellite, actuators display of scene categorization, and sensors is color pixel arrays. So here the agent takes the satellite images and based on the color pixel arrays, he will categorize the scenes into the different images. Then the next agent is the robot saucer player. Here the performance measure is to play, make goal and win the game. Environment is saucer and team members, opponents, referee, audience and saucer field. The actuators, navigator, legs of robot, view detector for robot, and the sensors can be camera, communicators and orientation and touch sensors. Now next agent is the autonomous Mars rover. Here the performance measure is terrain explored and reported. Collect, analyze and explore samples on Mars. So the terrain modeling is one of the performance measure. Then environment is Mars, launch vehicle, lander. Actuators are collection, analysis, motion devices, radio transmitter, wheels, legs. And the sensors are video camera, audio receivers, communication links, touch sensors, wheel or joint encoders, orientation sensors and accelerometers. So in this diagram, we can see the autonomous Mars rover. The next agent is the internet book shopping agent. So here the shopping of book is done by the internet book shopping agent. So here the performance measure is we have to minimize the cost. We have to provide the maximum information on the interesting books. Environment is the internet and the browsers that we are using. Actuators, add a new order, retrieve existing order information, display information to users. And the sensors, web pages, buttons or hyperlinks clicked by users. So we see the different web pages, we go through the different hyperlinks, we find out the information about the interesting books, then we place the order, we retrieve the information, and we have to minimize the cost like this. Then for the refinery controller, the performance measure is purity and safety. The environment is refinery and operators. The actuators are valves, pumps, heaters, display. The sensors are temperature, pressure, chemical sensors. Then the next agent is the theorem proving assistant. Here, the performance measure is time requirement, degree of correction, good maths knowledge, can prove theorem accurately and in minimal steps or time. Environment is the theorem to prove existing axioms, internet, library. Actuators are accept the right theorem, reject the wrong theorem, infer based on axiom and facts and display. And sensors are input device that reads the theorem to prove and that is we can take this information with the help of keyboard. So based on the different axioms and based on the information that we can gather from the internet or the library, then we have to prove the theorem. Now we have seen the different agents and we have seen how the PEAS is described. Now we'll see the properties of the task environments. What are the different characteristics that are exhibited by the task environments? So the first property is called as the fully observable versus partially observable. Now first we'll see what is the meaning of fully observable. If an agent sensors give it access to the complete state of the environment at each point in time, then the environment is effectively and fully observable. So if the agent is able to perceive the complete environment at a time, then the environment is said to be fully observable. If the sensors detect all aspects that are relevant to the choice of action, then it is fully observable. The example is crossword, part picking robot, and image analysis. Now, then what is the meaning of partially observable? If an environment might be partially observable because of noisy and inaccurate sensors or because parts of the state are simply missing from the sensor data. So if the agent is not able to perceive the complete environment at a glance, then it is called as the partially observable. Here we can give the example as a local dirt sensor of the cleaner cannot tell whether other square is clean or not. So if a agent is present in a particular square, then he will not able to perceive the presence of the dirt in the another square. So this can be the example of a partially observable. An automated taxi driver cannot see what the other drivers are thinking or what are the different obstacles that comes in the road. So this can be the example of the partially observable. Another examples can be poker game, backgammon game. The next characteristic or the next property of the task environment is deterministic versus stochastic. Now first we'll see what do you mean by deterministic. The next state of the environment completely determined by the current state and the actions executed by the agent, then the environment is deterministic. Otherwise it is stochastic. So based on the current action and based on the current state, if I am able to determine my next state, then it is called as deterministic. Otherwise it is stochastic. Strategic environment, deterministic except for action of other agents. So cleaner and taxi driver are stochastic. Because of some unobservable aspects, that is noise or unknown, taxi driver behavior of traffic can't be predicted. Other tires blow out and one's engine seizes up without warming. Cleaner randomly appearing dirt and unreliable suction mechanisms. So these are the examples of deterministic versus stochastic. Next property or the next characteristic is called as the episodic versus sequential. Now, what is an episode? An episode is agent single pair of perception and action. The quality of the agent's action does not depend on other episodes. If the agent action does not depend on other episode, then it is called as the episodic. Every episode is independent of each other. If my actions are independent of each other, then I can say that that is episodic. The episodic environment is simpler. The agent does not need to think ahead. An agent that has to spot defective parts on an assembly line bases each decision on the current part regardless of previous decision. Then what is sequential? Current action may affect all future decisions. So when my action depends on my previous action, it is called as the sequential. So here we can give the example of taxi driving and chess. So the example of episodic are part picking robot and image analysis, and for the sequential it is poker, backgammon and the taxi driver. Then the next properties or the next characteristic of the task environment is static versus dynamic. A dynamic environment is always changing over the time. If my environment is constantly changing, then it is called as the dynamic. Otherwise, it is called as a static environment. We can give the example of a dynamic environment is automated taxi driver. The roads are continuously changing. The scenario is changing every time. So this is the example of the dynamic environment. While static environment, we can give the example of a crossword puzzles. The environment is the environment remain as it is, so we can say the environment is static. Now there is one more type called as semi-dynamic. Environment is not changed over time, but the agent's performance score does affect. So this type of environment is called as the semi-dynamic. The example is chess played with a clock. So static environment example crossword, poker, backgammon. And the dynamic environment, taxi driver and the part picking robot. And the semi-dynamic example is the chess played with a clock or the image analysis. Then the next property of the task environment is discrete versus continuous. If there are limited number of distinct states, clearly defined percepts and actions, the environment is discrete. So if suppose I want to perform certain task and that task is to be performed in a defined number of steps, then that is called as a discrete environment. Otherwise, it is a continuous environment. So for the discrete environment, the examples can be a crossword, poker, backgammon, chess game. And for the continuous, taxi driver, part picking robot and the image analysis. Then the next property or the characteristic of the task environment is single agent versus multi-agent. So playing a crossword puzzle is a single agent where only a single person is involved. Chess playing, obviously we play a chess with two persons, then it is a two agent. Competitive multi-agent environment is chess playing where we compare with each other. We play a game in competition. Then cooperative multi-agent, execution of the task needs the cooperation. Example is automated taxi driver and avoiding collision. Then the next property or the characteristic of the task environment is known versus unknown. This distinction refers not to the environment itself, but to the agents or designers' state of knowledge about the environment. In known environment, the outcomes for all actions are given, possible to be partially observable. When we have the basic knowledge or the prior knowledge, it is called as a known environment. Example, solitaire card games, partially observable. You know the rules but still unable to see the cards that have not yet been turned over. If the environment is unknown, the agent will have to learn how it works in order to make good decisions. Can be fully observable. Example, new video game, screen may show entire game state, but you need to try buttons to know what they do. So here in this table we summarize all the examples and their categorization into different agents. So if the task environment is crossword puzzle, chess with a clock, then it is an example of fully observable, deterministic then sequential, and single agent. If it is a chess with a clock, then it is fully observable, strategic, sequential, semi-dynamic, discrete, and multi-agent. For a poker game, it is a partially observable, strategic, sequential, static, discrete, and multi-agent. For the backgammon, it is fully observable, stochastic, sequential, static, discrete, and multi-agent. Taxi driving, partially observable, stochastic, sequential, dynamic, continuous, and multi-agent. Medical diagnosis, it is a partially observable, stochastic environment, sequential, dynamic, continuous, and single agent. For the image analysis, it is fully observable, deterministic environment, episodic, semi-dynamic, continuous, and single agent. For the part picking robot, it is partially observable, stochastic, episodic, dynamic, continuous, and single agent. Refinery controller, partially observable, stochastic environment, sequential, dynamic, continuous, and single agent. Interactive English tutor, partially observable, stochastic, sequential, dynamic, discrete, and multi-agent. So here we have seen the task environments, what are the properties or the characteristics of the task environment and their examples. Now we'll see the structure of agent. So agent is what? The agent is architecture plus program. The job of artificial intelligence is to design the agent program that implements the agent function mapping percepts to actions. We assume this program will run on some sort of computing device with physical sensors and actuators. We call this the architecture. So what is architecture? Architecture is some sort of computing devices that are having sensors and actuators. Then what is program? It is a some function that implements the agent mapping, and the agent program is the job of artificial intelligence. So architecture plus program, this together are called as the agent. Now agent programs, the input for agent program is only the current percept. Input for the agent function is the entire percept sequence. The agent must remember all of them. The entire percept sequence must be known to the agent function. Then implement the agent program as a lookup table. As we have already seen, what is the difference between an agent function and an agent program. So agent function is just a abstract mathematical description, and its actual implementation is called as the agent program, and that is represented as a lookup table. So now here we see the example of the table driven agent. So this agent program is written as function table driven agent percept returns action. So what we are giving as an input to this agent? We are giving the percept, and in return what we are getting? We are getting the action. Therefore it is written as function table driven agent percept as input and returns action as output. Persistent percepts sequence initially empty table. A table indexed by percept sequence initially fully specified. So in the lookup table is maintained, which is initially empty, then we are going to make the entries in the table. We have to append the percept to the end of percepts. and based on the lookup table, that is based on the percepts and the table entries, the action is performed and we are returning the action. So this is the agent program for the table driven agent. An agent based on a pre-specified lookup table, it keeps track of percept sequence and just looks up the best action. Now, here I would like to mention some of the limitations of table driven agent. The first one is huge number of possible percepts. Consider an automated taxi with a camera as the sensor. Lookup table will be huge. If we consider the automated taxi driver and the camera as a sensor, then the camera continuously capturing the information, then you imagine the size of the lookup table. It will be very huge. So this is one of the limitation of the table driven agent. The second one is takes long time to build the table. As the number of entries, as the number of size is more, it take long time to build the table. Third limitation is not adaptive to changes in the environment. Requires entire table to be updated if changes occurs. So initially when we build the lookup table and if certain changes happens, then we have to again maintain the lookup table from the scratch. So these are the different limitations of the table driven agent. Now we'll see the agent programs where P represent the set of possible percepts. Then T represents the lifetime of the agent. Now what is the lifetime of the agent? The total number of percepts it receives. So from the first percept to the current percept, the total number of percept represent the lifetime of the agent. Then size of the lookup table. Consider the plain chess. If there are 10 set of possible percepts and the total number of percept the agent received, that is chess playing agent receives is 150, then we will require a table of at least 10 raised to 150 entries. So imagine the size of the table. Now, despite of huge size, the lookup table does what we want. The key challenge of artificial intelligence is find out how to write programs that to the extent possible produce rational behavior from a small amount of code rather than a large amount of table entries. Example, a 5-line program of Newton's method versus huge tables of square roots, sine and cosines. So now the time for the question and answers or the difficulties. We have seen in this video, we have seen the intelligent agent. What do you mean by intelligent agent? So the intelligent agent is what? An agent is anything that perceiving its environment through sensors and acting upon the environment through actuators. Then we have seen the diagram of the agent, how the agent perceives the environment, then how he will react to the environment. Then we have seen the difference between the percept and the percept sequence. Then we have seen the difference between an agent function and an agent program. That is, abstract mathematical description is agent function and its concrete implementation is agent program. Then we have seen one vacuum cleaner world example in detail, how to measure the performance of that agent, what are the different actions that can be taken, what will be the percept sequence for that agent, how the lookup table is maintained. Lookup table, we can say this as a agent function, how it is maintained for the vacuum cleaner world. Then how it is implemented concrete, it is the program or the agent program. Then we have seen the performance measure, then the environment, then the actuators, then the sensors for the vacuum cleaner world. Then we have seen the concept of rationality agent. That is, a rational agent is an agent which has the clear preferences. Then we have seen the example of a rational agent. So vacuum cleaner world, given the some set of constraints, it is an example of a rational agent. Then we have seen omniscient agent. then just omniscience and just the information gathering is not sufficient. We have to provide the learning also. So that we have also seen the autonomy and software agents. Then we have seen the task environments. So the task environment are described with the help of PEAS descriptors. So P performance, E environment, A actuator, and S sensors. So how to decide this PEAS, that we have also seen. Then we have seen the various examples of these agents and their PES descriptors. And then we have seen the properties of the task environments. Here we have seen the fully observable, partially observable, then deterministic versus stochastic, then episodic versus sequential, then static versus dynamic, discrete versus continuous, then single agent versus multi-agent. Then we have seen known versus unknown. Then we have seen the structure of agent. Agent is what? It is a architecture plus program. Then what is architecture? It is a some sort of computing device with sensors and actuators. Then what is agent program? It is some function that implements the agent mapping. Then we have seen what is the input for agent program, what is the input for agent function, how that agent function is implemented as agent program. Then we have seen the table-driven agent, how the agent program is written for the table-driven agent. Then we have also seen the limitations of the table-driven agent. Then we have seen the agent programs, where the P represents the possible percept, T represents the lifetime, and we have seen one example of the chess, how this lookup table entries affects the performance. So from these topics, the questions that can be asked in the exams are: explain intelligent agents with the help of examples. So here first write down the definition of the intelligent agent, then draw the diagram of the intelligent agent and explain that diagram in your own words. Then at least give one example of the intelligent agent. You can give the example of the vacuum cleaner world. We have seen the example of the vacuum cleaner world in detail. You can give that example also, or you can give any other examples also. Then the next question that can be asked as: what are the different tasks, or how the task environment is described? What do you mean by PEAS descriptor? So first you need to explain what is the meaning of task environment. So in this you can explain task environments are what? The task environments are the problems, while the rational agents are the solutions. And the task environments are described with the help of PEAS descriptors. Then they might ask you to write down the PEAS descriptors for different agents. So here you can write down the PEAS descriptors. We have seen the various agents and how to write down their PEAS descriptors. Here I would like to mention one agent. This agent PEAS descriptors is asked in the exam most of the time. That is robot meant for cleaning the house. Write down its PEAS descriptors. So for robot meant for cleaning the house, what can be the performance measure? We have to minimize the energy consumption. Then we have to maximize the dirt pickup. Then percentage of precision of cleaning. So we have to improve the performance of the cleaning. So this comes under the performance measure. Then the environment for the robot meant for cleaning the houses. House, obviously the house is the environment. Then the dirt distribution is also environment, but the dirt distribution is unknown. Assume the actions are deterministic and environment is static. Then actuators, jointed arm and hand of that robot. Then view detector for robot. So whether the dirt is present or not, it is perceived through the camera. Then orientations and touch sensors. the sensors to identify the dirt, and potentiometric sensors. So these are the sensors that are used to capture the location of the agent, that are used to perceive whether the dirt is present or not. Then actions or the actuators are jointed arm and hand. With the help of that, the robot will clean the house. Then depending on the position, depending on the dirt, the agent will be able to move to the left, he was able to move to the right. If the dirt is present, then the agent will suck the dirt. If the particular position is clean, or if the particular part of the house is clean, then the no operation. So in this way, the PEAS descriptor can be designed for the robot meant for cleaning the house. So we have seen the various task environments. Then the structure of agent. One of the possible example is the structure of agent. So here you can describe what do you mean by architecture, then what do you mean by program. Here you can give the definition of this structure, that is, the job of artificial intelligence is to design the agent program that implements the agent function mapping, percepts to actions. We assume this program will run on some sort of computing device with physical sensors and actuators. We call this as architecture. So here you can give one small example of an agent, then how the architecture and how the program is designed for that particular agent. You can write down the input, what can be the input for that particular agent for the agent program, then input for the agent function. Then if you want, you can mention the lookup table for that agent, then how that lookup table can be converted into a function. We have seen the example of a table driven agent, how the code is written for the table driven agent. So with the help of that code, we can write down the code for any particular agent. So up till now, up till this video, we have covered the intelligent agents, then introduction and definitions of artificial intelligence. Then in the next video, we are going to see the types of agents. What are the basic types of agent programs? There are the types of agents are such as simple reflex agent with internal state, agent with explicit goals, and utility based agents. So depending on the different condition and the action rules, the agent programs or the agents are divided into the different characteristics. The simple reflex agent, then reflex agent, then agent with explicit goal, and utility based agent. The roadmap represents the more sophisticated agents. So in the next video, we'll see the basic kinds of agent programs. So for this video, we have covered the weightage of the 10 to 15 marks. The intelligent agent can be asked for 10 marks. Then the task environments, that is explain the properties or explain the characteristics of the task environment. This question can be asked for 10 marks. Then the PES descriptor, again this PES descriptors can be asked for 5 to 10 marks. They can give you the agent and they will ask you to write down the PES descriptors. Or if they ask you just explain the PES descriptor with the help of example, then just you need to mention the PES descriptors and give the examples of the agent. Then the next question for the 10 marks is the properties for the task environments. They will give you the type of agent, that is automated taxi driver, or the crossword game, the poker game, the backgammon game, the image analysis. Then you need to categorize them, whether this particular agent belongs to the fully observable or the partially observable, or whether it is deterministic, stochastic, episodic or sequential, static, dynamic, discrete or continuous, single agent or versus multi-agent, known versus unknown. So hope this video will be helpful to you to understand the basic concept of intelligent agent, how their environment or the task environments are specified, and how the agent programs and how the agent functions are written. Thank you very much. Now in the next video, we are going to see the types of the agent, various types of the agent or various kinds of the agent programs. Thank you very much.